this is note-taking guide 9.3. We're talking about 3 different kinds of angles: central, inscribed, and circumscribed. On the first note-taking guide of this chapter, I actually told you guys what each one of these angles were, but today I'm going to teach you the rules that go along with it. So the first thing we're going to just remind ourselves of are that central angles touch the edge of the circle, the center of the circle, and then the edge of the circle again. So edge, center, edge. And if I know that this angle is 20 degrees, then I can actually find the measure of its intercept arc, because the degree measure of this arc measures the same as the angle does. So if this is a 20-degree angle, the arc's going to have a 20-degree measurement to it. Okay. Same thing here, 180-degree central angle. This one happens to be a diameter. So 180 degrees for that semicircle. This arc is also going to measure 180 degrees. Now I am 100% sure you guys could find this other central angle down here for me. Right? Couple of different ways. The first way is, you know, a semicircle adds up to 180. So you could do 180 minus 20. Or you could have done 360 degrees, subtract the 180 and subtract the 20. Either way you do that, what do you get for this angle right here? 160. And if this angle measures 160, what does this arc measure? 160. Okay. So now then, once we know how to do that, on our central angles, I could ask you something like this. I could say, what does U and F measure? What's the arc measure of U and F? So from U all the way to N, all the way around to F, how much does that measure? 340. Okay. That's the way central angles work. They help us to be able to find the arc measure. Central angles are the same as the arc measure. You guys good on that rule? All right, the next kind of an angle then is called an inscribed angle. If you remember when I told you the other day what an inscribed angle is, I told you it had to touch the circle in all 3 spots. Start, middle, finish. So angle A right here is the inscribed angle. Angle B right here is that central angle, right? So every inscribed angle can have a central angle. It also has what we call an intercept arc. Inscribed angles are 1/2 of their intercept arc. So if this arc over here is 70, what's this inscribed angle going to measure? 35. Okay, so the inscribed angle is 1/2 of the arc, which would also be 1/2 of the central angle, because the arc and the central angle measure the same. Okay, so we're going to use that rule in just a minute to solve some circles here. Then the last rule is a circumscribed angle. A circumscribed angle is this angle that's formed out here by 2 tangent lines. So here's my tangent line, here's my tangent line. This angle that's formed right here would be called the circumscribed angle. So here's my central angle to this angle, because do you see how it opens up to here? So I drew my 2 radii to the central angle to form it. My central angle is going to be called a value of x, which means my intercept arc is a value of x. And this angle out here would be supplementary to that, meaning 180 minus x will give us this angle. Here's the reason that that works. When you draw your tangent lines, and then we drew our radius over here twice, we know that the length of the radius is the same. And we know that these are going to form right angles. These are some rules that we're going to go over again in a couple more days. So I have here a shape called a kite. And in a quadrilateral that has special features like this, we know that opposite angles are supplementary. So we know these 2 angles here have to add up to 180. Okay. We're going to use that rule again in just a minute just to make sure that you have it good. Okay, so here's the example one. Use circle A to find the measure of arc BC. Now, just a reminder, you guys, they're minor arcs if they're represented by 2 letters, right? And they're major arcs if they have 3 or more letters. So keep that in mind as we're looking, okay? So it says to find the measure of arc BC, arc CD, arc DE, and arc BE. So really what I want to do is I want to find the circle and then answer those questions. So first of all, do you guys see these little marks right here that mean the same? I know that this arc and this arc measure the same. Do I know the measure of this arc right here? 32. So guess what this arc's going to measure? 32. It also means that this angle is going to measure 32 because the angle and the arc measure the same when we have central angles. Okay? Now, tell me this. Could you find this angle over here for me in case I need it? I can because 360 degrees is the total circle. So find that angle for me.
I just noticed that you put an F in for this assignment.
I know, put it in and I'll look at it in a little bit.
Okay, thank you. Please change that as quick as you can, because seeing a C in there, it just hurts my heart.
241.
Okay.
Okay, thank you.
All right, how much?
241.
241. Do you guys agree with that? Yeah? So 241, which means this whole arc is 241. So let's go back up and answer the questions. What does BC measure? 32. What does CD measure? Good, it's 65. Yeah, DE is 32 and BE. Now remember, this is the minor arc, which really means it's going from B to E this direction, right? Because this one would be a major arc. So from B to E this direction, how many degrees does that measure? 129. Thank you. Questions on how I found those angles and arcs. So again, central angles and their arcs are the same. All right, this one says find. Now notice this right here, you guys, and some people have made mistakes throughout the day on this. This asks you for the angle this time, right? So make sure you're reading whether or not it's the angle or the arc. So this says find the measure of BAC, which would be from B to A to C, so this angle right here. Now I know this arc length is 60. This is an inscribed angle. Does anybody remember the rule about inscribed angles compared to the arc? 1/2 of that. So if this is 60, this is 30. Nice job. Okay. So the angle measures 30 degrees. Then it says find arc FE. So again, it's a minor arc because there's only 2 letters. So from F to E with the minor arc is this direction. If this inscribed angle measures 70, what's this arc going to be?
70.
Okay.
Wait, 140.
Yeah, remember double it because of the inscribed angle. So it's going to be 140 degrees. Okay. Questions on how I did that? All right, this next one then is called a circumscribed angle. It's an angle on the outside of the circle formed by 2 tangent lines. Now we had a rule here that said, if I know this arc, how do I find this angle? Anybody remember?
180 take away 116.
It is. It's 180 take away 116 because those 2 angles, the angle and the arc, have to be supplementary. So 180 minus 116 is 64. So that's going to be 64 degrees for that angle out there. All right, before we even get started, tell me what kind of angle this is so we know what kind of rule we're using. That's inscribed, right? It's inside the circle. It touches all 3 spots on the circle. So if I know that this inscribed angle right here measures 95, can I find this whole arc over here?
Yeah.
Okay, how much is that whole arc?
Isn't it going to be 95 or 95?
Is it half of it or is it double it?
Or double it?
Yeah, you got to double it. So what's it going to be? 190. So this little piece is 75. This big piece is 190. Can I find my question mark now? Because what do I know the whole circle adds up to be?
360.
Yeah, so we're going to do 360 minus 190 minus 75. And what do you get for that arc? 95. Questions on how we found that one? All right. 2 more examples and we're done. This is a major arc I'm looking for. You guys agree with me? I know it's major because it's got 3 letters there. So I'm looking for the measure of that major arc from C to F to D. So C, F, D. So all the way from here to there. So in order to find that, I'm going to have to find these missing pieces here, right? So that I can do that. So I want you to notice that that's a diameter. Do you guys agree with me? That's a diameter, which breaks my circle into 2 semicircles. Anybody remember how many degrees are in a semicircle? 180. So how much does this piece have to measure right here?
Small one?
Yeah,
45.
45. Now that I have that, can you guys tell me the angle relationship between those 2 angles right there? This one and this one. They're vertical angles. And what do you know about vertical angles? They measure the same. Then I could totally find that missing angle right there, because what do I know these 3 angles have to add up to? 180. So do 180 minus 45 minus 81.
54.
You guys agree 54? Okay, now let's answer the question. How far does it measure from here all the way around to here? Well, I know this arc's 135. I know this arc's 45. I know this arc's 81. So I just have to, oh, I also need this one, which is 45, right? I couldn't see my pen there. So I really could add those together, or I could have taken 360 and just subtracted off this one that I'm missing, right? Either way, I get the same answer. What's the measure of that arc? 306 degrees. Thank you. Questions on that problem? All right, one more to go. Here we go. This.
3 what?
I'm sorry, what?
306.
306.
And you just add all those up to get there?
Yep, we just added all of them up from C right here all the way around to D right here. Okay. All right, last one right here. We're finding arc MP. So arc MP is this arc right here. And I'm finding angle MLP. So MLP, I need this angle right here. Okay, this angle that's marked is a central angle. So if this is a central angle, what do I know about the arc right here? It's the same. Yeah, it's 165. Okay. Now, if this is 165, does anybody remember how to find the circumscribed angle? Yeah. So 180 minus 165, which is how much? 15. So I know the arc was 165, and I know the angle is 15. Okay, one more thing I want to point out on this one, just in case there's a problem like this on your assignment, which I know there is. Instead of being given this angle right here, what if they gave you this one, this arc over here? Couldn't I still just find that arc because I know this big arc over here and the little arc add up to how much? 360, right? Because it's the entire circle. So if they give you this arc over here, just subtract it from 360 to find this arc, and then subtract from 180 to find the angle.